Today we're learning about scientific notation. Scientific notation, so we should be on page 74 in our books. Page 74. Scientific notation. Now, one thing you need to know about scientific notation, we are not solving anything. We're not even changing the value of the numbers. All we're doing is writing it a different way. Scientific notation is a way that we can write really, really huge numbers in a simple way, okay? That's all scientific notation is. Do I have your attention? Everybody paying attention? Okay. All right, so in example 1, okay, in example 1, we're writing numbers in scientific notation. So here's how we do it. We look for a place in this number, okay, between two digits that will give me a range that is greater than 1, okay? So it has to be greater than 1, but it has to be less than 10, okay? And X stands for that number, all right? So to write a number in scientific notation, it has to be bigger than 1 and less than 10. It has to be in that range, okay? So I look for a place where I could put that decimal. And in 110,000, it's going to be between the ones, okay, 1.1. So I would write that 1.1 times 10, and now I count how many places I had to move my decimal to get to that new number. And I moved it 1, 2, 3, 4, 5 decimal places, and that will be my exponent. So I write a number in scientific notation by finding between what two digits give me that number between 1 and 10. Okay, does everybody agree that 1.1 is bigger than 1 and less than 10? It's in that range? Okay, so I know that that's the correct number. I had to move it 5 decimal places, so that's why I have 10 raised to the 5th power. Now on 1,350,000, does anybody think that they know where my decimal needs to go to give me a number between 1 and 10? Where would I need to move my decimal? Between what two numbers? Anybody think they know? Stephen?
1 and 3.
Very good. Between the 1 and the 3. So now, and get this, okay? You have to write every number that is in this number, the 1,350,000. So it will be 1.35, okay? Not just 1.3. It needs to be every number. You don't include the zeros, but it has to be all the numbers. 1.35 times 10 to the, and now I count. My decimal was here, 1, 2, 3, 4, 5, 6. 10 to the 6th power. Okay? Now, even with smaller numbers like 4,500, I can write this in scientific notation. Where would my decimal need to go in this number? Carlos? Between the 4 and the 5. Very good. And so now to write this in scientific notation, I would say 4.5. And now I count how many decimal places? 1, 2, 3 times 10 to the 3rd power. It will always be multiplied by 10 to some power, okay? And remember, the exponent is simply how many decimal places I had to move to get to my new number. All right, now I'm going to restate what I just said before this example. I am not changing this number. 1.1 times 10 to the 5th power, if you put that in your calculator, you would get 110,000. Same thing with the other two examples. All we're doing is writing it in a shorter version. That's what scientific notation is. Okay? Does anybody have a question on example 1? All right, I'll go ahead and pause the recording to answer questions. All right, let's move on to example 2. Now, in example 2, you see that we already have the number in scientific notation. Okay? Now we're going backwards. We're going from scientific notation to standard form. Now, here's the key. To write a number in standard form, the first thing I want to look at is this exponent. Remember, the exponent, when writing in scientific notation, tells me how many times I move my decimal, right? So the exponent will tell me how many decimal places to expand the number by. Okay? So I have a 7. Where is the decimal with the 7? Just a 7. Where's the decimal? Where is it? It's behind it, right? Okay? So the 3 tells me to expand this number by 3 decimal places. 1, 2, 3, and fill in the zeros. And so my answer is 7,000. Okay? That would be in standard form. Again, all I'm doing is manipulating this number. I'm not changing its value. 7 times 10 to the third is the same thing as 7,000. Okay? Now with 4.398 times 10 to the 8th, again, I want to look at the exponent. The exponent tells me how many decimal places to expand the number by. So I have 4.398. Okay? 10 to the 8th tells me how many decimal places am I expanding by? Class?
8.
8. Very good. So I go 1, 2, 3, 4, 5, 6, 7, 8. And in each one of these troughs, I'm going to fill in a 0. Now, please do not make this your answer on your homework. I want a clean answer, okay? You can put the commas in there that will just help you, but this is going to be 439,800,000. That's a big number. How many of you wish you had that much money in your bank account? Or your parents did? Yeah, me too. Okay? Yeah. Now, notice too that your decimal, the decimal is not between the 4 and the 3 in my answer. I still get kids putting that decimal, but remember, when you're writing in a standard form, you're moving your decimal however many places the exponent tells you, okay? So the decimal is now after that last 0 in my answer. So make sure that you remember to do that. You might want to rewatch this video over the weekend when you're doing your homework. All right, because you do have a few of these on your quiz on Monday. All right, now example 3, comparing numbers in scientific notation. Which one is bigger? We're comparing moons on a planet. Okay, so they use the planet Mars, and they say that one of the moons, its mass is 1.06 times 10 to the 16th. And the other one's mass is 2.4 times 10 to the 15th. Well, you can't just automatically say, well, 2.4 is bigger than 1.06, so that one's bigger. We can't say that because the exponents are different. Now, if the exponents were the same, then yes, you could compare them that way. All right, so here's how we would solve. Let's see. All right, sorry about that. I should have written it side by side. Okay, so the first thing you do whenever you're comparing numbers in scientific notation, all right, is you look at the exponent. If the exponent is the same, then you just look at the decimal. And you compare which decimal is bigger. If they are different, like they are here, if they're different, then the larger exponent will always be greater. So since 16 is greater than 15, that is going to be my answer. Okay? So whenever you're comparing numbers in scientific notation, look at the exponents. If they're the same, look at the decimal and compare which one's bigger. If they're different, then the larger exponent will always be a larger number. Right? And if you understand that, I believe that is everything you need to know for 2.5.